Greetings and good day to everyone. Today we are here to have a discussion on a device known as Field Programmable Gate Arrays, that is commonly heard as FPGA. As for our presentation, we will be focusing on the application of FPGA in aircraft pressurization system. You might have heard of FPGA before from somewhere, but might not be clear on details of its functionality and how is it being used to carry out a certain task. Basically, FPGA is an integrated circuit that contains many identical logic cells, around 64 to 10,000 of them, that can be viewed as standard components. Each logic cells can independently take on any one of a limited set of personality. The individual cells are interconnected by a matrix of wires and programmable switches. Each logic cells combines a few binary inputs to one or two outputs according to specified logic function in the user program. These are a few examples of system that is present today in an aircraft. As shown in the slide, besides these four uses of FPGA, it is also used in flight computers, cockpit display, engine control and monitoring system, braking system, safety warning system, and power control. FPGA is also widely used because it attributes to reconfigurability and designed to work in part-time much faster compared to traditional systems such as ESIC-based platform system. Reasons why we chose pressurization system is just simply to describe a system which operates under usage of FPGA. When an airplane is flown at high altitude, it consumes less fuel for a given airspeed than it does for the same speed at lower altitude. In other words, the airplane is more efficient at high altitude compared to cruising at low altitude. Pressurization system also helps to stabilize indoor ventilation and maintain cabin pressure. As shown in the following diagram, hypoxia effect is a pathological condition in which body suffers lack of oxygen distribution around human body cells. This is an example of FPGA that is used in aircraft Boeing Dreamliner 747, which is Pro ESIC 3. Pro ESIC 3 have their own ability and advantages. This is a single chip, live up and power up solution that combines high performance and high reliability with non-volatile condition. Pro ESIC 3 is also immune to neutron-induced configuration upset. This immunity is essential to overcome neutron radiation, which is common when aircraft is flying at high altitude. The working flow of FPGA in pressurization system, in simple explanation. Start by Peter tube collects reading of outside aircraft pressure at specific altitude. That can be explained from the following diagram. We can calculate dynamic pressure by finding the difference of total pressure at pressure gauge with the pressure at orifice to obtain dynamic pressure. Then, analog data is converted to digital signal by using analog to digital converter, as shown in this figure. Signal reaches inside FPGA logic box, then those data coding is analyzed to allow it to carry out a specific function. Next, the coding is then sent as an output from FPGA logic box and directed to cabin pressurization system. Finally, the cabin pressure is adjusted to its required condition. Earlier was an explanation on how FPGA works by itself, and now we will describe how the system works with FPGA board. This is how FPGA works with the system. Based on the following diagram, ECS, Environmental Control System, is responsible to control all main systems in an aircraft. ECS is controlled by FPGA as well. To observe in detail, this following diagram will describe the flow. Bleed air from gas turbine is compressed. Then it goes into ECS, which is programmed by FPGA. Next, the pressurized gas enters the heat exchanger cycle machine. From the heat exchanger cycle machine, pressurized gas goes into the cabin. The cycle of the flow goes out to ECS as well. ECS controls gas going out and in of the system by OFV, which is known as outflow valve. When the valve breaks down, there is other alternative ways to control the system, which is by manually adjusting two valves. These valves are PPRV, positive pressure relief valve, and NPRV, negative pressure relief valve. So just to shows details in clear path, this is the sites and several page that helps us to obtain data and research info to complete our task. These sites has contributed a lot of information in order for us to complete this particular assignment. Well, that's all from us today. We hope you enjoyed our simple presentation. Thank you.